So we'd like to introduce you to a new form of a line today. Hey guys, let's come to order, please. Ladies and gentlemen, we're gonna begin now. Okay. Thanks for talking, Sabrina and Rosie. And okay, all right, we're gonna begin talking about normal form of a linear equation. Our last lecture of this unit, and if you guys would stop talking, that'd be great. So I know it sounds a little weird to be talking about the equation of a line as our culminating semester lecture, but it's something that can only be done now with knowledge that you have, even though you've already you're like, does this belong in Algebra 1 class? Standard form, point-slope form, Slope-Intercept Form. Another form of an equation of a line that maybe you should have learned in Algebra 1 or something. Well, no, not really, because you'll see that normal form involves a definition that includes an angle. So I'm going to start by showing you a picture. So what is normal form? This is another way to describe a line using two parameters. In Algebra 1, you might have used two things, like the slope and the y-intercept, or the slope and one point, or three numbers A, B, and C, or something like that for standard form. So that's the same idea here. We've got two things that we're going to hand you, and with just those two pieces of information, you're going to be able to come up with a unique line in the plane that's described by just these two parameters. One of the parameters is P. It's the length of the normal to the line, which we'll explain what that means in a second. And phi, the angle that the normal makes with the x-axis. The picture is worth 1,000 words. So here we've got a green line that we're trying to describe somehow. And here's the way we're going to do it. We're going to drop a perpendicular segment from the origin to the green line. So those are perpendicular, the green and the blue line. Keep in mind the green line is the one we care about. But we call this blue line, the perpendicular line to the green, we call that the normal. And the length of that normal, that segment called the normal, is P, is what we're naming that length. And the angle that that little blue segment makes with the positive x-axis, that is in standard position, is phi, or phi, however you like to say it. And I claim that just giving you those two parameters and that understanding of what we do with them, that's good enough to define a unique green line in the plane, right? So I'll describe why I think that's true with kind of a little visualization here on it. So imagine I was to say, all right, I need you to point in the positive x direction and turn 120 degrees. So I'm first giving you, maybe I'm giving you 5, right? So to point in the positive x direction and then turn 120 degrees, and then walk 10 feet, right? And then when you get there, spread your arms out like that, and there's your line, right? Does that make sense? So that defines a unique line. If I tell you I need phi to be 120 degrees and p to be 10, you and you and you all of you draw that line, you'll all come up with the exact same picture. Do you agree? Because that's what I mean by describes a unique line in the plane. Those instructions aren't ambiguous. Do you agree? Yeah.
So the normal hits the line perpendicular.
Correct. Yep. Perpendicular is what we're thinking of that blue line being. And by the way, normal is one more math word that means the second of 3 different words that you'll learn this year for the word perpendicular. You know the word perpendicular. Normal also means perpendicular. And then there's one more word that we'll learn in Unit 7 that means perpendicular as well. Normal. The word normal, in terms of why that means perpendicular, if you've got any experience in physics, or I don't know, maybe they talk about free body diagrams and POE and stuff like that, right? So maybe you've thought about something called the normal force, or maybe you've heard someone say right now I'm standing normal to the floor, right? It's the force perpendicular to the surface here in this case. Okay. All right. So now I'd like to play my project now. Eventually, as usual, eventually I will be putting this in a box. But right now I'm just trying to get my way to the Algebra 1 on this. How can I get to stuff like Algebra 1? I could write the equation of that green line. If you gave me P and phi, the goal is if someone hands me P and phi, I'd like to be able to write the equation of that green line. So I'm going to derive that just by hand using things from Algebra 1 that I know about this picture. What I'd really love to know is I don't know, how about the coordinates of this black point? that I've just placed on the intersection of P and the green line. So what are the coordinates of this point if someone tells you that the distance here in blue is P, and you know that in practice that'll be a number like 10 or something, and you know this angle phi, maybe it's 60 it looks like in this picture or something, but they tell you what those are. Can we come up with the coordinates of this? Keeping in mind that the x-coordinate, by the x-coordinate we just mean this distance, and by the y-coordinate we just mean this distance. All right, so what is it? Let's start with the x-coordinate. What is that? How do we come up with that? I hear you say p cosine phi. Why? Yeah, so the cosine of the angle phi is equal to x over p, isn't it? The cosine of this angle, I dropped this perpendicular line to just this dashed line to make sure you're seeing the triangle here. The cosine of our angle phi is equal to x over p. Therefore, x is equal to p sine phi. And similarly, y, which is this distance here, is equal to p sine phi. Do you agree? Huh? Did I say it the first time? Wrong.
The first time you said p sine.
Oh, I'm sorry. P cosine phi and p sine phi on the y-axis, on the y-phi. And that piece of logic, like you've probably gone over that in your head before, haven't we? Like, for instance, when we were trying to find the height of a triangle, do you remember that it was the side near the angle times the sine of the angle to find the height of that triangle when we're doing like ambiguous case and stuff like that? We're just saying we've thought about this before is the point. We've thought about that idea before.
Oh, and that's the coordinate of the black one.
Those are the coordinates of the black point, just using like trig. There we go. We just did it using trig. Also, like if p happens to be 1, then remember that the black point is on the unit circle. Okay? And the coordinates are just cosine, comma, sine. So these are all things that you've thought about before, I think. The next thing I'd like to think about is the slope, just for fun, is the slope of the blue segment. Now, keep in mind that we just discussed at length what is the rise and the run, so to speak, right? So, yeah, it's this thing over this thing. It's sine over cosine, or p sine phi over cosine, p cosine phi. The p's cancel off. If you want to write that as tangent phi, that'd be perfectly great. Yeah, and then some of you are already jumping to the real question we wanted to answer, and that's what's the slope of the green line, which is ultimately what we care about. And that's negative cotangent, you're welcome to write, or how about negative cosine phi over sine phi? Just the negative reciprocal, the opposite reciprocal. So those are things we've thought about before, but you see how we're trying to set ourselves up for like algebra 1 success here, right? Now that we know a point and the slope, I think we have the equipment we need to write the equation of the line, right? I have using like algebra 1 technology now. Okay. By the way, it should just be like a matter of interest that the angle, maybe you've never thought about this, but the angle that any line makes if it goes through the origin is just the tangent of, the slope of any line passing through the origin is just the tangent of the angle it makes to the positive x-axis. I don't know if you've ever thought about that. With this blue line, you just thought about that, but maybe you've never equated tangent theta with slope, the slope of a curve, or the slope of a line going past the x-axis. But that's what it is. I mean, that elevates the importance of tangent in my mind a little bit if I haven't thought about that before. All right, let's just summarize what we've learned. So far, we've got a point in black, and we've got the slope of that green line over here in black. And now I'd like to come up with the equation of this line. If I have a point and a slope, then I think there's a form I remember maybe from algebra 1 called the point-slope form. Can someone describe what that is? Y minus something, something, yeah. It looks like this, something like that. That will become an increasingly more important equation in your life as you move toward calculus. It's like the king of calculus. We're going to use that all the time in calculus. So it's worth learning and worth bringing up again. If we apply that in this situation, we can just plug in the things we know. Ready? Go. Plug them in. And we have a little bit of cleaning up to do, but just keep in mind that in the end, p and phi are constants. So Everything in that equation is a constant, except for x and y, which are variables. Of course, those are still our variables for the line. But everything else is a constant. And if we clean this up a little bit, I think that we're going to see something nicer than what we're currently seeing. I'm going to start by multiplying through by sine phi. You can see why I kept it in the way that I did, rather than having it be cotangent. I'm going to multiply everything by sine. I'm going to multiply out the right side just for fun. I'm going to move everything over to the left side. I refuse to slow down. And then I want you to just stare at where we're at here. We're just doing a little bit of algebra here. And see if you can predict my next move. But all of that stuff was pretty, I think, pretty predictable, the stuff I was just doing. I'm just moving stuff around a little bit.
And moving the dust.
Yeah, can you see that I'm going to maybe, it's almost irresistible. I feel like I need to take out a p out of the right two terms, the rightmost. And then why would you do that, and what makes that exciting for us? Yeah, that's one. And now I think we're ready finally to put it in a box. There it is. It's in a box. That's called normal form of a linear equation. Again, keeping in mind that phi and p are constants. X and y are variables. So as usual, the derivation was interesting, but in the end, there it is in a box. Okay? I just want to explain everything that we do as often as I can. I want to make sure we kind of understand where these things come from. Yeah.
So is p always going to be attached to 0, 0?
Yeah. Yeah.
Okay,
Attached
so
to 0, 0. Yeah, sure.
Yeah.
Yeah. Wherever your line is, we're drawing a perpendicular segment from the origin to the perpendicularly from the origin to your line, and that's our segment of length b. If the line runs through the origin, then we still can maybe think about the angle a little bit. I mean, we can think about that. But p will just be 0. Yeah.
So how do we get p? How do we get p?
I'm supposing at this point, right now at least, that someone gives you p and phi.
Oh.
But we'll talk about the other way around too.
Wait, no. How do you get the angle?
The angle will be decided based on the coefficients on x and y. If someone doesn't tell you, that's how you figure it out. We'll see. And we can handle once we go through the origin too. All right, so here's how you get an equation in normal form. Start with your equation that might be in standard form. How about? And divide through by the square root of a squared plus b squared, which sounds a little bit familiar. Like maybe we've thought about the square root of a squared plus b squared before. Like maybe even on Thursday, right? We were thinking about something very similar. I've kept this up in a box over here, but it kind of makes sense to me that this is supposed to be a y. It kind of makes sense to me that we might want to be doing that because ultimately on x and on y, I need coefficients that are the cosine and the sine of some angle. And right now, a and b might be something bigger than 1, right? And by dividing through by this, it guarantees that we have, in fact, the cosine and the sine of an angle. Use whichever, I said plus or minus, use whichever makes the c value, which will, after doing this, will be the p value. Whatever makes the c or the p value negative, right? Just because that's like our kind of canonical form. And then once you've done that, I mean, you're done. The length of the normal is just sitting right in front of you. After having divided through, it'll just be there. You'll just be able to say that's p. It'll be a little less obvious what phi is, but that's okay. We've already kind of been through this logic, even again, like the warm-up today. Phi will be the angle that has a cosine of whatever the x coefficient is, and a sine of whatever the y coefficient is. Okay. Again, all kind of coming from the red box up there. Once we have it in that form, then whatever the coefficient is on x and whatever the coefficient is on y, we know that that's got to be the cosine sine of our angle. If we know the cosine sine of our angle, we should be able to get our angle, even if it's no matter where it is. You might have to use a calculator. That'd be okay. Anything. Okay, the next thing I'm going to do is do an example, which I think that a couple examples will be helpful. But conceptually, is that? P will be the new C. Yeah. Yeah. It'll be C divided by this thing. Right? Every coefficient gets divided by this new thing. Square root of a squared plus b squared. And then the coefficients then will be, the coefficient on x will be the cosine of your angle, the coefficient on y will be the sine of your angle, and the constant term will be p. Okay. Anyone still need this for a second?
Does that mean that the normal would be in any quadrant? If you had a normal that was in quadrant, like 3 or 2 and the other ones?
Absolutely. Yep, yep. Because your line could be anywhere, right?
Yeah. So then you would just have to know where
All right. So I'm giving you on this first one, I'm just handing you p and phi, and I'd like us to come up with the equations. So here we go. I'm just copying off of that box. I'm just like trusting Mr. Chase that he was right. Okay, it's, what do I do? It's x cosine phi plus y sine phi minus p equals 0, right? This is what the box said. So here we go. It's x cosine of 330 plus y sine of 330 minus 11 equals 0. 330 is a nice angle.
Yeah.
So actually I can name what these things are. The cosine is positive root 3 over 2 x minus 1/2 y minus 11 equals 0. So we're doing pretty well here. It says put it in standard form, and now I need like a refresher on algebra 1. I don't even know what standard form means. I think what we want is something capital A times x plus something capital B times y plus something C capital C equals 0. And I think we want capital A to be positive and maybe free of any fractions, stuff like that. I don't know, right? So do whatever you want. Standard form, I think the general idea is like make it look pretty, okay? So do whatever you can. Maybe we multiply through by 2. I don't know, whatever. And by make it look pretty, I mean make it look like this. I mean look at how pretty that is. Come on now. Doesn't that look so pretty? Sorry, my board is breaking again. Alright, we're going off-road. Alright, here we go. So, root 3, excuse me, I'll say that again. Root 3x minus y minus 22 equals 0. Would be a great way to write this, okay?
And what do you do?
If you want to multiply by root 3, you could, I guess. I don't know what the rules are. It's not necessarily possible to make a an integer always, right? I mean, you could I don't know. I think that's a little artificial, but this is maybe prettier. Yeah. So we'll call ourselves done with standard form. Say that one more time. I think we should try and clear the fractions at least. Someone could also ask you to get this in slope-intercept form, which you could easily do. It's root 3x minus 22, right? That would be slope-intercept form. And let's just check our intuition on this too. Let's just check our intuition on this. If before we did any of this, someone asked me to draw a sketch of this line, I might be like, okay, 330 degrees. Stop talking. Okay. I'm gonna go 330 degrees, and I'm gonna go out 11 units, right? And then I'm gonna draw my line. Do you agree that that's what I'm saying? Okay, that's what we mean by p and phi. Now, I also want to just kind of check our intuition based on like our algebra 1 knowledge. I just said a second ago that this is the slope-intercept form of the line. Does this look about right qualitatively? Does it look like it has a slope of root 3 and a y-intercept of negative 22? I think we're doing pretty well. I mean, if you were to extend this down, I just did this really quick, so I don't know. But apparently they're the same. Apparently this is the slope-intercept form. If you like the slope-intercept form better, yeah.
On quizzes, will it like specifically say standard form?
I mean, I will be a little flexible. I don't know, because I don't. No. All right, let's try going the other way too. I've given you an equation here, and I don't know what you want to call this. Again, maybe we call this standard form. But in the end, I want this to be in normal form, and I'd also like to know what p and phi are for this line. So we might start by using our, we haven't done this yet, we want to use our easy one-step process. We're going to divide through by
5.
No.
Why not?
By 5? Well, you can divide through by 5. I hear what you're saying. But then you'll also have to divide through by something else. That's fine. You can divide through by 5. I don't mind.
What do you want us to divide by?
I want you to divide through by, what did I say on that slide? Square root of a squared plus b squared, which, whatever, and we also want to, well, actually before we do that, I might move over just because that's the way it looked. This is the way it's been looking on our other slide, so I'll write it that way. All right, and now I'm going to divide through, I feel like we've done this one before, yeah. We're going to divide through by something here. And I apologize again, the board is not doing well right now, so I'm going to go back over here. I keep kind of messing it up.
What? Did you add the two
All right,
together?
so,
And we did this problem earlier this morning.
yeah, we did this one already. What do you end up dividing by?
You end up getting root 3 over 2 x plus 1/2.
Yeah, it's 5 root 3 squared plus 5 squared. But in the end, that's just 10, right? Like I said, we've already done this algebraic gymnastics before. But actually, I'm going to divide through by negative 10. All right.
Why?
Because I'd like this to be minus p at the end, okay? So here we go. When I do that, I get negative root 3 over 2 x minus 1/2 y minus 17 equals 0. And now my guarantee to you was that is now in normal form. Like that was my guarantee, even though it's a little hard to see and you're trusting me. Even though you're kind of trusting me that that's true, I did say that all you had to do was divide through by negative 10 and then boom, it's in normal form. If that's the case, what would happen if someone gave you this, by the way, and said, hey, convert this to normal form? Well, you might proceed by like being like, well, I need this to divide through by the square root of a squared plus b squared. What do you think the square root of a squared plus b squared is in this box equation, this new equation?
1.
Happens to be 1, right? So if you tried to convert this to normal form and it was already in normal form, you'd find yourself dividing by 1. Can you explain why, in terms of your trig knowledge, why that must be the case, that this thing squared plus this thing squared equals 1? Yeah?
Because sine squared plus cosine squared.
Yeah, this is, I guess, this is the cosine, the sine of an angle, right? So, that was an excellent explanation. Yeah?
Why do you want the negative? I thought we wanted
In the end, we're going to report it as 17. And let's do that right now. P equals 17. In the form of the equation, we had a minus p, though, is what we said. The other way you could write it, you could also have equals positive p on the other side. I don't know, I've seen it both ways. All right, so we're also supposed to write down p. It's 17. Once we have it in normal form, we're just going to trust that we've got it. It's there. P equals 17. And then phi is a little bit harder to see. It's the angle
So it's
that has a cosine of negative root 3 over 2
so it's in this.
and a sine of negative 1/2, which again we've thought about already today.
So it's in the third quadrant. Or third quadrant. No, it can't be 100.
What angle is that?
It's 210.
What'd you say? 7 pi over 6.
Which is 210.
Right? So that should make sense. That's the angle we're looking for.
Do you want to write an angle or does it matter?
You can write in either form, radians or degrees. Is that what you're asking?
Yeah.
Okay. Didn't say, so I guess we're fine with either one.
210.
All right. In the last 2 minutes, to see if I can say something about the distance from a point to a line, I'd like to.
Why is that important?
I'd like to say something interesting here. All right. So one question that an Algebra 1 student might be scared of is, how far away is this line that we just did from the origin? And by that we mean
10.
like how far away is this line from the origin if you draw a perpendicular segment from the origin to the line? Well, we now know the answer to that is just 17, right? It's just, for that last line was 17. And that seems like easy. It's like, yawn. But for an Algebra 1 student, that would be difficult. They'd be like, wait, what? I've never been asked that before. How far is this line away from the origin? Another thing that would scare an Algebra 1 student would be to find the distance from a line to any point, not just the origin. Okay? And the way we can do that is using this formula right here, which is exactly the thing we've been doing. Normally, if we plug in a point that's on the line into one of these equations, like this last equation, if we plug in a point that happens to be on the line, then it satisfies the equation, right? And what does it spit out over here if you plug a point in for x and y that is on the line? What will you get over here?
0.
You'll get 0 because it satisfies the equation. But if you plug a point into this equation, this is like the big cool moment. If you plug a point into this equation that is on the line, you get 0. But if you plug a point in that's not on the line, you get something that's not 0. But it's not garbage. Turns out that that number is how far away it is from the line. Okay? So that's like a really useful thing.
Show us really fast.
I'm going to try and do it in the next 60 seconds. We'll see how much we can get into. The first goal here then is for me to get this into normal form first. And then once it's in normal form, I'm just going to plug in -1/7. If I get 0, that means it's on the line, and the answer is 0 units away. If I get a number like 5, then it's 5 units away. I also need to pass out the homework worksheet, so this is going to be a little complicated here. And the board is broken. Okay. I keep trying. I keep trying.
Right.
All right, so I'm multiplying through by 3 first. I'm going to multiply, just to clean things up a little bit, right? I'm going to move everything over to this side. I get -2x plus 3y minus 24 equals 0. What do I have to divide through by? 4 and 9 is 13.
What? Oh, because
Yeah.
you do that
All right, and then the distance will be, don't leave yet. Don't leave yet, Alex. Say it again.
No, it's actually like.
Dude, I need to give you a worksheet here. Alright, hey guys, the homework is on this worksheet today. It's homework 9 and 10 you're doing. Look at the board. Look at the board.
Does that work? Does it work or not?
And you can just get the eye.
I know, I can do that. What's next? I already have one. I don't need any chance.
You'll see. Once you read in your...
I don't know. It's probably on the sheet.
Alright, is everyone successfully get a worksheet?
Just your sheets. Just do all the odd ones, right?
Yeah, all the odd ones on both sides of this.
Yeah, it makes sense.
See you guys. What does that come out to? 2 plus 21.
Make her run.
See you guys.